This is major in 2025, and these are the grade thresholds for A, B, and C. So the first question is about scalars and vectors and distinguishing between them. I'm going to just quickly go through them. Acceleration is a vector, displacement is a vector, because energy and scalar, speed is scalar, temperature is scalar. Constant resultant force F acts on a car M, and he's wanting you to prove this, that the kinetic energy can be found using this, or can be found using this logic, and ends up at this location. So we start with the idea that the work done is simply force into distance, and we can replace ma in place of force. And for the acceleration, we need to use this equation, which is v square equals to u square plus 2as. And since the car starting from rest, the initial velocity will become 0. So we're looking for the acceleration. This becomes a equals v squared divided by 2s. And then we simply put this back as a into this equation. So this becomes m into v squared divided by 2s multiplied by the distance, because it's in the same direction as the displacement. So this will also be s. So what we're left with is mv squared divided by 2. This s cancels out with this. And the work done comes out as mv squared divided by 2, which can be simplified that the work done is equal to the gain in kinetic energy is equal to half mv squared, and this is hence shown. This used to be mentioned in the syllabus but was not frequently asked, but this recently I found that they are asking about proofs too. The mass of the question, the mass of the car is 920. It starts at t0 for 5.8 seconds. The car starts at rest. Its velocity today is 17 meters per second. He says, what's the kinetic energy? So simply applying the formula, half into 920 into the velocity that is gained at 17. But don't forget about the square. This is going to come out as 132940 joules, and up to 2 significant figures, this will be 1.3 × 10⁵. Next question, between T0 and T5.8, work done against the resistive forces is this much. Determine the average power output of the car during this time. So let's find out the total energy from the engine. So the energy from the engine is equal to the energy spent for the kinetic energy gain plus the work done against the resistance or drag forces. So that will be 1.3 into 10⁵ plus 4.7 into 10⁴. That's the total energy spent on everything. And the power is equal to energy divided by time. So the time for which this happened is 5.8 seconds. This all happened for the duration of 5.8. So total energy divided by time taken for the process will eventually give us the power. So the power comes out as 30517, which is going to be 3.1 into 10⁴ watts. He says at time t.5, the speed becomes constant. He says, what is the power output? Is it greater than, less than, or the same just before 5.8? You see, since no more energy is needed to change the kinetic energy, the only energy required now is to overcome the resistive forces. Hence, the power output is less, or the power output has to be less. So it simply goes like this. So the power is equal to total energy divided by time. So this is the energy to change kinetic energy, for example, or to gain speed, plus the work done for drag, friction, and resistance components divided by time t. Since right now the object's moving at constant speed, the only energy required is to overcome the drag and the friction components. There is no energy needed for kinetic energy, so this vanishes, which leads to a smaller numerator, leading to a smaller power requirement for maintaining of speed. Question 2. Moment of force is product of force and perpendicular distance from the pivot to the line of action of force. If you're familiar with the definition, memorize them from the marking scheme. That's the best strategy to go forward. Now, this is a question that's going to be a bit difficult, and we're going to solve this in 2 ways. I'm going to show you 2 perspectives, which I generally talk about this as students with me, that this can be solved in 2 ways. So let's do it this way. It's up to you. I'm going to zoom out a bit to make more space. This will eventually look like this. Okay. So the first perspective I'm going to solve over here on the left is going to be from the perspective of distance. If we were confused about the distance or perpendicular distance, how do you visualize that? And the second one is going to be from the perspective of the force dealt with reference to the angle. Now, the clockwise moment has to be equal to the anti-clockwise moment, and we understand that this is the point of gravity, this is the weight, and the distance from the pivot up to the weight makes an angle of 90 degrees, which is very straightforward, which means that the clockwise moment, which will be, again, let's start from the basics. So this should be sum of all the clockwise moment should be equal to the sum of all anti-clockwise moment. This will be the force into distance equals force into distance. This should be mg of the weight of the tree, which should be 270 into 9.81 multiplied by the distance or the perpendicular distance between the line of action of force to the pivot, which is 1.2. This side is not the problem. The problem is on the other side. How to visualize the distance perpendicular? You see, if we extend the line of action of force like this, then the actual distance should be QP. Now, because we're dealing this from the perspective of the distance, I'm going to draw the triangle again one more time. So this is how it's supposed to look like. We're supposed to find out the distance between Q and P. And the angle, for example, this one is 90. If we continue down this road, this one is 90, right? And this should be the angle theta. And we are given the distance, which is this one, which is 1.6 from this point to this point. I want to find the distance between Q and P, which is the hypotenuse of this triangle. So this should come down as 1.6, for example. Something like this. So this will be cosine of theta equals to 1.6 divided by QP. So QP equals 1.6 divided by cosine of theta. Now I can use this line of action of force with 1800 very straightforward. So F, I'm not disturbing F, this is 1800, but I have considered the distance to be the perpendicular one to the force, which is supposed to make a 90 degrees angle. So this one is going to be 1.6 divided by cosine of theta. So once you solve this, the theta comes out, of course, don't forget about the cosine inverse. Once you solve this, the theta comes out as 25. And you've successfully shown this. Now let's do this question with the perspective of force in mind. How do you visualize force? Now, the same logic goes for this question as well. So this is going to be clockwise moment equals to anti-clockwise moment. The clockwise moment is not the problem. This is still the same. 270 into 9.81 into 1.2 equals anti-clockwise moment. This time around, we dealt with the distance being perpendicular, but what if I don't want to change the distance? I want to make sure that I do consider 1.6 as my distance. I want to consider 1.6 as my distance. But if I want to do that, then I cannot consider 1800 directly. I cannot do that. I need to make sure that the component of force is also in the same direction with the component of distance to make an angle of 90 degrees. I need to make sure of that. So I would have to visualize this in a triangle that looks like this. So this is the force F that is given to us as 1800. This is that triangle that's going to be formed with an angle of 90 degrees, and this is that angle theta. And I'm trying to find out this force F dash that is in the upwards direction, because if I extend that, only that comes out at 90 degrees with 1.6. So the way to look at this would be to again apply trigonometric ratios, because I'm trying to find out the hypotenuse. This would be cosine of theta equals to 1800 divided by the F dash. So since I'm trying to find the F dash, this will be taken to the side. This becomes F dash equals to 1800 divided by cosine of theta. And this is the F force that's going to be required in this situation. So this one, if I wanted to use 1.6, this will be F into D, of course. This is F into D. But this time around, this is going to be 1800 divided by cosine of theta multiplied by 1.6. Notice, is there any difference? Because this one also is divided by cosine theta. This one also is going to be overall being divided by cosine of theta. So the answer is going to be 25 again. But this is a matter of perspective. I've shown you two perspectives that you could have used to solve this question. And it doesn't matter which one you choose. Now, this question is a bit tricky, and I've shown this question to the students many times that this is going to be part of the answers now. Is asking you to draw a scale diagram to represent what weight, normal reaction, and the force F is doing. So a basic idea would be like this. This is the weight. This is the force F that was given to us 1800. And this should be the normal reaction like this one, R from the ground up. Because according to the loop rule, if the triangle completes a loop, the system is in equilibrium. And if it is in equilibrium, there should be a loop like this one. But now is the time to draw it accurately. What you're supposed to do, and we'll discuss the procedure with you, but then I'm going to show you the answers. What you're supposed to do was this. So you were supposed to use a ruler and measure the whole length of the weight. Now, according to my calculations, this comes out as approximately, I think, 12.1 centimeters. It could be different for you because if you try to print this paper or you get this from any bookstore as past papers printed, there might be slight variation. But my calculations, or at least from my printing side, this was 12.1 centimeters long. And the weight, since this was 270 multiplied by 9.81, this was 2648 newtons. So that means that the scale of this diagram is actually 2648 newtons represented like this. Now, I know that there's going to be a force in this direction, which is 1800 newtons. How do I use the same scale to convert it back? So for the sake of F, I replace 1800 here, place X here, and do a cross multiplication. I'm led with X being equal to 8.2 centimeters, which means that using a ruler, I'm supposed to draw F up to 8.2 centimeters in this direction. But what should be the angle? Now, is the angle given in the question? That is exactly why he gave you a show that question previously. So he wanted you to show that the theta is 25. So you could have used this idea in the next diagram. So don't forget that if there's a show that part, it's going to be used somewhere else in the question. So you place a protractor here, measure the angle 25 exactly. I'm exaggerating this. Of course, this is not 25. Measure the angle 25 and should be up to a length of 8.2 centimeters. So by basic geometry, you will find that this is going to come out approximately somewhere along this side. Now draw this line. This will be 25. This should be 25. This should be 8.2 centimeters. Again, according to my calculations, my diagrams, you could have printed this differently. You may or you will get different answers. So no need to worry about that. You need to worry about the procedure. And this should be the arrow for F, as you can see from the diagram as well. This is the arrow represented by the F, right? Now, in order for this to be in equilibrium, there needs to be another force going in this direction to complete the triangle. So we don't know what that is, right? We don't know what R is. So it's your job to complete or use a ruler in this way. Once you've made this, to draw a straight line to join these points together. This is your R. I might have asked you about R later, right? So could you have found that? Yes, you could have. So if you measure the length of this and use the same scale by your measurement standard, you could have found the value of R as well. So that's how you visualize the question. Is this only one way of doing this? No. If I show you, for example, another diagram, yes, you could have done it this way as well. So there are two options to do these questions. So it's always, let's say, going this way or going from this way. It does not matter. Yeah. So the way he's going to check this is that this should make an angle of around 37 degrees. It's up to you now. Okay. And make sure that you are as accurate as possible. Use a very sharp pencil for this, and always make sure that you do this with a pencil, because if you make a mistake, you can do this again. Okay. All right. So we're going to move on to the next parts now. Yep. All right. He says the tree exerts a pressure 150 kilopascals on the top of the post. Determine the surface area of the tree in contact with the post. So this is simply pressure equals force over area. Pressure is 150 into 10 raised to power 3. You will be ignoring this small k. Please don't do that. This is kilopascals equals to force, which is 1800 divided by A. Draw a line, show the presentation. A should be equal to 0.012 meters squared. This should be 0.012. Question number 3. This is about waves, progressive water waves, X and Y, travel along the straight line from point A to B. We don't know where they're at, that point A and B is, but anyways, the displacements are given, everything is given to us. He says the amplitude of wave X is very straightforward. This is 10, right? This should be 10 centimeters. And then both waves have frequency 16 hertz, and so on and so forth. So determine the speed effects. So speed is equal to V equals to F lambda. The F is given to 16 hertz, but do we have a wavelength? Can we go back to the diagram? Yes, we can, because it's distance on the x-axis. The crest and the trough covered here actually represent a wavelength now. So this should be 0.4. Right, so the lambda is 0.4, and we have to be careful about the axis. This is meters, okay, fine. Now I can say that this will be 6.4 meters per second. So this is 6.4. It says state and explain whether X and Y are coherent. So as you can see that they're both having the same wavelength, they're definitely coherent, right? So X and Y have constant phase difference of 180 degrees, so they are coherent. They are actually 180 degrees apart. They have a phase difference of 180, but they have the same wavelength. They have approximately, probably will have the same frequency as suggested. So they are coherent. Wave X and Y are superposed, or they're going to superimpose to form a resultant wave. This is a good question, and it's repeated in MCQ sometimes. That's a good question. Now he wants you to show this on the diagram. The reason it's 2 marks is because it's very simple. No need to worry about this. So first find out where the displacements are 0. So this is 0, 0, 0, 0, 0. The changeover points are not different. So it's going to be this coordinate, this one, and so on. They could be different from this, but it doesn't matter. Now, we're going to find the instantaneous displacement at every place. Luckily for us, most of the time, since this is 180 degrees out of phase completely, we just have to find the displacement by adding them. So 10 with minus 20 at this peak, the result of these two waves should be minus 10. So this is one coordinate. The next time around this comes along again, this is now positive 20, and this is now minus 20. So the resultant displacement is simply the addition of these two displacements or amplitudes. This one is going to be like this. And soon you recognize the pattern that is going to go like this one. And then you simply draw a wave through them like this. Make sure that the line is very smooth, smooth transitions. Obviously, because of my limitation, I can't do that right now, but you can do it better, I hope. So this will be the final answer. This is again a good question used to come in MCQs, but here is given to you as a P2 question. He says, the density of X is X and Y is Y. Determine using figure 3.1. Let's go back to 3.1. This is 3.1. He says X has an intensity IX. Y has an intensity Y. He's wanting you to find out the ratio. And we understand that the intensity is proportional to the amplitude squared. So if he wants me to find out Ix divided by Iy, it should be amplitude X squared divided by amplitude Y squared. Now, since they're both being squared, what we can do is also write it like this. Ax divided by Ay whole squared would not matter. Write down the formula first and then put in the values. This will be Ix divided by Iy equals to 10 divided by 20 whole squared. This is going to come out as 0.25. The answer is 0.25. Let's move on to question number 4. In question 4, there is a ball dropped from certain height. For example, like this one. It's a situation like this. Ball is dropped. Then it bounces back up again, right? Okay. So he says everything is given to you in this situation. Let's dive into the question directly. Explain whether the collision is elastic or inelastic. Now, to determine that, you can see that the speed it falls with is 0.5.2, but the speed it rises up is 3.6. If it was elastic, then the speed of collision should have been the same. Or you can say that the relative speed should have been the same. So the kinetic energy is being used as a logic. So kinetic energy before and after the collision are not equal, hence it's elastic. It's a 1-mark question. You could have used this logic or the relative speed approach logic. But it's coming as 5.2, should have risen back at 5.2. He's asking, calculate the change in momentum of the ball during the collision with the ground. So this will be change in momentum equals to Final momentum minus the initial momentum, which will be 3.6 into 0.25 minus 0.25 into minus 5.2. You see, the object was falling down, so the velocity is taken as negative. When it's rising back up again, the velocity is taken positive, which is why this becomes the final momentum because it was rising with the speed, and this becomes the initial momentum because it was falling with the speed. And because of the falling, there's a negative, and this negative is because of the fact that we're finding the change. This is due to mathematics, or English translated to mathematics, but this negative is because of the convention, vector convention, that all objects moving downwards are taken negative velocities, all moving up are considered to be positive velocities. So this is going to come out as 2.2 Newton seconds or kg meters per second. So this is 2.2. This is determine the average force during the collision with the ground. So for the force, we need some time. Is time given to us? Yes, the time is given to us. It was in contact before 0.18 seconds. So force is equal to rate of change of momentum, which is delta P divided by delta T, which should be, no, not 5. It should be 2.2. Yeah, this. So this is 2.2 divided by 0.18. This comes out as 12.22 newtons, which will be 12 after two significant figures. And then he's asking us to calculate H2 by H1. Now, consider this. So the falling height is H1. The regain height is H2. And he's asking us to find the ratio between them. So let's find them part by part. Let's say this is the height H1 it was introduced from. It was left, or it was dropped from this height, gained a speed of 5.2 meters per second before colliding with the ground. So can we use this information to find the distance H1? Yes, we can. So we have one way, this is v square equals to u square plus 2as. The final speed is 5.2 whole squared equals, it was released from rest, so the initial is 0, plus 2 into the gravity, which is 9.81, into s, which is h1. So h1 comes out as 1.38 meters. Now let's try to solve this for h2, the rebound height. So it was released, for example, it jumped back up again with a speed of, given to the question, is 3.6. So it jumps back up again with 3.6, right? So this should be, and we want to find out how high it can go. So when we say maximum height, then that means that at this point, the velocity should be 0. So in this case, this will be v squared equals to u squared plus 2as once more. But since it's going up, the gravity is going down or is acting downwards, there will be a negative sign with it. And this time around, this will be 0 squared equals to 3.6. Is it 3.6? Yes, it's 3.6. So 3.6 whole squared plus into 2 into negative 9.81 into h2. Now, when you take to the other side, this will have a negative value with it. So don't worry about this negative sign. Even if you don't add it because you know they are acting against each other, you still understand that how to go with this value. So this h2 comes out as 0.66 meters. So it's a ratio. So this will be 0.66 divided by 1.38, and we get 0.478. So this becomes 0.48. Now, could you have solved this with another logic? Yes, you could have. There's a gravitational potential energy converting into kinetic energy. This is mgh equals half mv squared. But notice what happens with mass. Mass cancels out, and we're left with an equation that looks similar to this. It's not that different. So for the h, it would have been h equals to v squared divided by 2g. If you rearrange this equation, you will end up with the same equation looking like this. So you could have used the energy logic here too for the first part and for the second part. Depends on your idea and knowledge base. Question 5, he says, define the Young modulus. It's very simple. Equation, definitions, everything is given to you. Question is given in terms of force. There's an extension. Be careful, this is extension. That means that he's not considering the original length in this case, but it is mentioned 0.81. Determine the cross-section area of the wire. This is a 3-mark question, a good question, not that big of a deal. So Young's modulus is equals to FL divided by cross-sectional area into change in length. The Young's modulus is given to you in the question, that is 95 gigapascals. So this Y should be 95 into 10 raised to the power 5 equals the force. We can choose a point that is exactly on the line, which is 500 on the force scale and 4 millimeters on the extension scale. So this should be 500 multiplied by 0.81. Where did we get the length of 0.81? That's given in the question as 0.81. And then we get divided by cross-sectional area, which is A. This is the purpose of the question. And then we are left with the change in length, which is for 500, it is up to 4. So this will be 4 into 10 raised to the power minus 3, because it's millimeters. And then you're supposed to show the formula, putting in the values, and then you simply write down, or you don't need to show the algebra, you just need to write down that the area, or whatever you were trying to find out, is 1.1 into 10 raised to the power minus 6. So that's how you get the full credit for this. Part 2, he said the initial extension was 2, the final extension is 3, find out the work done in doing so. And we understand that it's the area for the force extension graph to go from 2 to 3. So it was at this point already, it has been stretched to go up to 3. So the area covered in these locations is this one, is this area, right? This value, if you check this from the graph, is going to come out as 375. Counting the appropriate boxes, please print this out. And this is approximately 250. So the sum of parallel sides, I'm going to use the area of parallelogram for this one. So please mention that it is the work done is actually equal to the area under a graph from 2 millimeters to 3 millimeters. So this will be half into sum of parallel sides, which is 250 plus 375 into the distance between them. The distance between them is 2 to 3. Okay. So that will be 3 into 10 raised to the power minus 3 minus 2 into 10 raised to the power minus 3. And this should give you an answer of 0.3125 joules. This will become 0.31. Let's move on to question number 6. He says, define electric potential. We understand how that works. It's energy transfer to the component per unit charge, because if you remember, this is voltage equals to work done by charge. This is joules per coulomb, right? Now let's look at this question. Please study the diagram properly. Just have a look and then move on to solving the question. Don't just dive into it directly. This is a very easy question and a very nice question in terms of developing concepts. It's not that difficult. But anyways, so let's discuss the question before moving on. There is 0.03 amperes of current coming into this junction. Some of it is going to go into this branch and some of this is going to go into this branch. Now, fortunately for us, we understand, we know the resistance of this branch in total. So we can calculate I1 before moving on, but let's see if the examiner demands it or not. Determine the charge path of the battery in 4 minutes. So this will be Q equals to I multiplied by T. We understand that this current is actually coming from the battery, or is being originated by the battery, created by it. This will be 0.03 into 4 minutes converted into seconds. This will become 7.2 coulombs of charge. So this should be 7.2. He says, as expected, he's going to ask you about the current I1 because the easiest one to calculate. Now, imagine that this branch and this branch, they're both parallel to the battery. They both have easy access to the battery, which is why they are being referred to as being parallel to each other. Okay. All right. So the access to this branch is V equals to IR, I1R. The access voltage they have is 8. The current I1 is, we don't know. Since it's the second branch, they are connected in series. We can simply add their resistances together. This should be 430 plus 240. So I1 comes out as 0.0194 amps, which is going to become 0.012 amp. Now, before moving on again, let's decide on something. We have 0.03 coming in at this point. This is still 0.03. Something going this way and something in this branch. This something is 0.012. We've calculated that. And if I subtract this 0.012 from 0.03, I can get the current from this branch. But let's see if the examiner is asking about that. That's exactly what he did. So I2 is equal to the current entering the junction is 0.03 minus the leaving junction, that is 0.12. So I2 becomes equal to 0.018 amps. And then he's going to ask you about the resistance R, which is mentioned in the first branch, I guess. Yep. So since the first branch currently, so this whole branch has access to 8 volts because it's in parallel. We know the resistance of the first resistor, but we don't know about this one. But we have found that I2 is 0.018. Now this makes our life very easy to solve. So according to V equals to IR, the potential difference available is 8. The current in the branch is 0.018. The resistance combined should be addition of 210 with R. So it's simply 210 plus R. A bit of algebraic manipulation leads to R being equal to 234.44, which makes it 230 up to 2 significant figures. Part C. Now this is a question that usually comes in P1. This time they've asked us in P2 as well. This is generally called a Wheatstone bridge, but that's not how it's referred to in your course, so no need to worry about that. He says, what's the condition? Reference to the ratio of resistance. Explain how the circuit can be used to determine the value of X, which we don't know. So it goes something like this, that if this ammeter or voltmeter reads 0, that means that the branches are balanced, which means that 210 multiplied by X, 430 multiplied by this unknown resistor should be equal, which looks something like this. So 210 multiplied by resistance of X equals 430 multiplied by the resistance of the variable resistor. Now, if you go to the marking scheme, he's going to talk to you about the ratios of stuff. He's going to say that the ratio of 210 with 430 is equal to ratio of the variable resistor with the ratio of the component X, which is not wrong, by the way. But we look at this in terms of the products of opposite branches. When the ammeter, again, is 2 answers. When the ammeter or the voltmeter reads a 0. But since in the question he's mentioned that this is probably an ammeter. Yeah, it's a galvanometer, which is a very sensitive ammeter. So this is how you write this down. Okay, when an ammeter reads 0, the ratio of resistance 210, 430 will be equal to the ratios of this. And I would recommend, because you have a lot of space to write down, I would recommend either do this or do this. Write down an equation. And always remember, if you write down an equation, then always explain the variables. That if you write, for example, if you write down 430 multiplied by resistance VR equals 210 multiplied by Rx, then please explain that Rx is the resistance of, let's say, the component X, and RVR is the resistance, so on so, of the variable resistor. Don't use variables without mentioning what they are. Okay. Question 7. Very straightforward. He says, what is meant by fundamental particles? The particle cannot be subdivided into smaller particles. He says the nuclear. This is a new part. And this is a good question because it makes you think like a nuclear scientist. And that's the main idea, that how do we identify charges is by their charge to masses. That's their identity. Protons, neutrons, electrons, positrons, they all have an identity or a fingerprint that's based on charge to mass ratios. But anyways, that's a discussion for A2. So it says that the charge to mass of something is given as 4.1 power 7. All right. It's given to us like this. Let's see. It has 14 nucleons. We don't know what the combination is. So it could be protons plus neutrons equal to 14. We don't know how many protons, we don't know how many neutrons, but we do know is charge to mass. So let's move on. Let's find out the number of protons. So this charge to mass is given to us as 4.1 into 10 to the power 7 equals, what charge should there be? So let's say protons should bring in a positive charge, which is 1.6 power minus 19. And a neutron should bring in no charge because they have nothing on them. They are neutral. Now, what should be the mass of the system? Because it has 14 nucleons, protons and neutrons both have a mass. So this 14 should be multiplied by the atomic mass unit, which is 1.66 power minus 27 kilograms. Now, all of this leads to the calculation of P. So if you balance everything out, if you perform the correct algebra, P is going to come out as 5.955, which rounded off becomes 6.0. So this nucleus should contain 6 protons and approximately 8 neutrons. Nucleus X undergoes beta negative decay from nucleus Z. It's a matter of putting numbers again. So since he's talking about probably X, and today we know that if this is proton, this should be 8 and this should be 6. Yep, this is 6 now. And if it decays with beta, so this should be beta, with 0 again, this beta negative, so this is -1. So nothing happens on the top number, which is going to stay 14, but 6 becomes 7 based on this equation. Okay? And the one thing that comes out with this one is electron antineutrino, which has 0, 0. That's how you get full credit for this. I was saying that a sample of radioactive sample emits particles that are positively charged and have a continuous range of kinetic energies. Now explain whether they are alpha particles or beta positive particles. Now, you start with the honest comment that it could be either alpha or beta positive based on the fact that the charge on it is positive. But alpha particles have discrete energy levels. Their kinetic energies, when they exit from a decaying nucleus, half mv square, is a fixed value. So it's a discrete energy, it's a fixed value, it's not a range of energies. Only beta particles, be the beta positive or negative, have range of kinetic energies when they exit, which is why they have curvy and thin lines in a cloud chamber. And that's why we comment that only beta particles have, or beta emissions have range of kinetic energy. So this must be a beta positive particle. Okay. That is all for today. I'll see you around.